Okay, Integrated Math 3 fans, our topic for today, this is section 1-2 and 1-3, perpendicular lines justifying constructions. And before we begin, let me give you your joke of the day. What do you get from a pampered cow? And the answer is spoiled milk. So the goal for today, there are a lot of different kinds of constructions. The idea of construction is we're going to make something. We are going to construct a relationship. And the ones that we're going to look at make constructions of a perpendicular, angle bisector, congruent angle, and parallel lines. And then we're going to justify them using some proof. So not only are we going to do them, but then we're going to look at why they actually work. Now, for constructions, probably you've seen something like this. This is called a compass. This is the traditional way of doing this, where you'd put like a pencil or something here, and you would hold this up, and you would turn it, and you would be making arcs. Now, I'm going to use a different one. Okay, this is called a safety compass here. I find this to be a little bit better. But the idea is the same, is that I'm going to use this tool to basically make arcs or circles. So just to show you, I'll do it on the back here. The two parts that I talk about, there's the part, this is called the bullseye, which is where I'm going to put my finger there. And then you'll notice this part here, this red piece, it actually slides. I call it the setting because I am setting the distance, or how big my arcs will be. There's actually two holes on here. Now I can put the pencil into either one. If I put it into here, and then I turn this, and what I have is a circle. Now, one thing that I did not do, which normally I would want to do, is actually to place a point to make that my center. So you see the size of that circle. If I had, so I'm going to put this is my anchor, like my bullseye. I'll put the point right in the middle of that, and then I use my finger to anchor this. So as I turn this around, this does not move. This stays where it is at the center. And then if I had used the second hole here, just to show you how big this circle is, and I go around, and you'll see there's a little piece here where I didn't quite get all the way around. That's okay. That's a much bigger circle. Okay, so it's kind of cool. You can draw circles and draw very good circles with this. What you have to be careful about, and it's the same thing, if you're using this, the anchor is this piece, the sharp piece. You put that at the center, and then you keep it there as you turn this, and it draws the circle for you. The problem I have with this is that it tends to slide. It moves. And if it moves, then the circle is going to be off. So one other thing about this, you want to do this on a hard surface, on a flat surface. And if you're using a notebook, I wouldn't do that because for two reasons. One is you have a bunch of pages, and the pages will press up and down, which makes it a little harder to get a nice curve, a nice circle. The other thing about a notebook is at the edges you run into the binding, and so that can be a problem. All right, so we're going to start with a very basic construction here, and it's called a congruent segment. So if I take a segment like AB, here's an example, and I want to copy that. I want to draw a segment that is congruent, which means the same shape and the same size. So congruent, the symbol for that is the equal sign with the wave on it. Congruent basically means the same shape and the same size. Now, the other thing about this is that normally I like to use pen to do this, but the pencil is a little bit thicker, which I actually like a little bit more when I'm doing this. So to construct this segment, what I'm going to do is I'm going to draw a ray. And a ray has one endpoint. Okay, so here's a ray. And then it just goes indefinitely in the other direction. I'm going to call this point A with a little mark, A prime, which means it's corresponding to A. So what I need to do is I need to figure out, well, here's AB. Where would I put B prime so that these two segments would be congruent? Obviously, this is longer than AB. So I need to figure out where to put B prime. Now you might be thinking, the other thing, if you look at my compass here, is that it has a ruler on it. And you might say, Mr. Cavell, why don't I just measure this, which is about 3.5 centimeters, and then I can do 3.5 down here and put a point there, and then I'm done. And the answer is, well, you can, but the problem is that that's not going to be perfect. It's going to be close, but we have to do some approximation to figure out, well, 3.5, we can get real close to it, but it's not going to be perfect. By doing a construction, if we do this correctly, it should be perfect. So from A to B, here's what I'm going to do. I'm going to take my anchor, my bullseye, and I'm going to put that right on top of the point A. Now, you'll notice that the holes of the setting, if I use them, I can make little arcs here. What I want to do is go right to B. I want to measure the distance to B. So I anchor on A. I can slide this piece so that the hole goes right on top of point B. Now, it's a little hard to see with the video, but this is right on top of B, and I'll show you by drawing a small arc right here. Notice that it goes through B. So then I'm going to come down to A prime, anchor there. I'm going to use the same setting and the same hole, and I'm going to draw my arc. And where it intersects is B prime. And if I measure this now with the ruler, I have 3.5. These are congruent to each other, and I can say that segment AB is congruent to segment A prime B prime. Okay? Now you'll notice that I put a different segment here, CD. So if you want to practice this, you can also use what I've given you here to try to construct C prime, D prime. All right, now let's go to one that's a little bit more complex. We're going to draw a perpendicular bisector of a segment. The symbol for perpendicular is an upside down T, and perpendicular, remember, means 90 degrees. Okay, so right angles. And then bisector means to cut in half. So what we want to do is we're going to take this segment EF, we're going to cut it in half, bisect it, and we want to draw a line that's going to create right angles as well. Now the key to this is that when I use my setting and I slide it, if I slide it to create distance, whatever I do from point E, I have to do the same thing from point F. I have to use the same setting and the same hole. If I am not consistent, then this is not going to work. All right, so let me take you through the process here. I'm going to anchor on E. Now my setting is actually, it's fine. Where it is good. The rule is that it has to be more than halfway. And the reason why that's the case, well, I'll show you in a minute. Now here's what I'm going to do. I'm going to take this and I'm going to draw an arc above and below the line. I'm going to arc above and below. Now you'll notice I just made one big arc. You don't have to do that. You can just draw kind of a smaller arc up here and then a smaller one down here if you want. But notice they're part of the same. So you might find it easier to just do that. So what I did, I anchored on E and I drew an arc above and below. Now what I'm going to do is come over to point F and anchor on F, and then I'm going to draw the same arc. Now the key thing, and I'm going to turn my paper to make this a little bit easier. Actually, I'll turn it upside down. I'm going to do the same thing. I'm going to arc above and below with the same setting, the same hole, the same setting. And notice that what happens is the two arcs cross, they intersect in two places. Okay, I'll turn it back around. What we did was we just created two new points here. I'm going to label those points of intersection A and B. Now the last thing that I'm going to do is connect A and B. I will use the straight edge. I'll use the straight edge, which is just the ruler part here. And let me connect that. Now two things, hopefully, have just happened. The first thing is that we've created a midpoint. I'm going to call that M. Because the other thing about a bisector of a segment, yeah, a bisector cuts this in half, but that means that that halfway point is a midpoint. So M is a midpoint, and I can verify that by measuring from E to M, which is about 2.8 centimeters. So 2.8. And then from M to F should be the same, hopefully. Look at that, 2.8. So that means these are congruent. So M is the midpoint, which is good. And then the other piece to this is that this line should create a right angle with EF. Now, you can look at this and say, gosh, that kind of looks like it's 90 degrees. So that's the cool thing with a construction. If it looks good, it probably is good. You have probably done this correctly. Now I can use, on my compass, there's a very small protractor, so I can try to measure. This isn't going to be very accurate, but wow, look at the 90 pointing right onto the line here. So that does look good. That's a perpendicular bisector. And the key, when I am trying to figure out my setting, the key thing is that when I anchor on E, however I draw the first arc, I have to use the same measurement when I draw F. If I make it too small, just to show you, let's say that I made the setting really, really small. Okay, you're going to see what happens here pretty quick. If I draw the arc, oops, pen's not working, there we go. Okay, there's my arc from E. Now when I turn it, when I draw the same arc from F, notice that what happens is that they don't cross. The arcs are not long enough, they're not going to intersect, therefore I can't connect those points. Okay, so that's the key. Now, there's one other thing we're going to do with this. If I take point A, for example, and I connect A to E, and if I connect A to F, we've just created a triangle here. Now, by the way, this is not the perpendicular bisector. We're adding on to this now, okay? If I measure from A to E and A to F, what's going to happen is that these are going to be congruent. This is an isosceles triangle. I have created an isosceles triangle. Now what's kind of cool here is that let's say I pick a different point. I'll pick a point down here. If I connect that point to E and to F. And I'll take the ruler here and just show you. That's about 6 centimeters. And this is about 6 centimeters. These two segments are congruent. And what happens here, you can take any point on this perpendicular bisector, and that point will be equidistant from the endpoints of the segment. No matter where I put a point on the perpendicular bisector, it will be the same distance from the endpoints of the segment. These are congruent, these are congruent. If I took right here, I'll just freehand it. I guarantee you, assuming that I draw those correctly, those will be the same. And that's going to be true 100% of the time. And in the second video, I'll show you why.